Hello, everybody. I'm Jeffrey Schnapp. I'm the Chief Executive Officer of a Boston-based company named Piaggio Fast Forward. I'm also a professor at Harvard University, where I run a lab called the Meta Lab. And the talk that I'm going to present today, which is going to include a live demonstration of a robotic vehicle that I'll be talking about in the course of this presentation, is a talk that's entitled Movability. And as you'll learn from this talk, the concept of movability is a concept that comes to suggest what the future of how we move around the world might look like. You know, whereas mobility took place on the kinds of stages that we associate with the Industrial Revolution, the open seas, the sky, freeways, and its actors were the heroes of the industrial age, these incredible mechanical contraptions that reshaped the world, like container ships, airplanes, automobiles, trucks, and trains. What I'm going to suggest is that movability unfolds on a different kind of scale, on a more intimate, intelligent, fine-grained human scale of the 21st century cityscape. And it's the scale of autonomous land drones threading their way down busy sidewalks. It's the scale of smart cargo carts invisibly coupled to workers making last-mile deliveries. It's the scale of microcars platooning like trains while stopping off at individual destinations. It's the scale of civic spaces animated by smart new kinds of vehicles that extend the range of the activities of sectors of the population that haven't been well served by automobiles, like the disabled, like the aging population. But before we get too far ahead of ourselves, before we plunge forward into the future, let's focus a little bit on the present that is familiar to all of us. And contrary to the feverish promises of turn-of-the-century, 20th century futurists, the romance of the road is driving humanity down a dead end. The civilization of speed, acceleration, and motorized mobility is transforming the world into a perpetual traffic jam. Entire cities are being sacrificed on the altar of automobility. The landscape is being reduced to a flyover and a drive-through zone, fracked to extract fuels whose combustion is literally cooking the globe. And as all of you know, over 80% of today's city spaces are wrapped in dense and noxious blankets of pollution. And even better, or even worse, people aren't moving more, they're moving less, and with greater difficulty. And they're facing the health consequences of leading sedentary lifestyles. Now, all the while, transportation has been undergoing a massive change, maybe the biggest transformation that it's undergone since the era when automobiles first started reshaping how people move around the world. And these transformations are forcing us to ask important questions. Questions like, how are we to harmonize the evolution of vehicles and modes of transportation with our existing infrastructure? And maybe even more importantly, how are we to develop healthy and sustainable models of community and infrastructure? Not the ones we inherited, but new ones that are meaningful to us. And in the process, we have to answer some other questions. Among those questions, how do we do so in a world in which goods and people are moving differently? They're moving at a finer scale, not in bulk the way they moved during the industrial era, but at an increasingly fine-grained scale, and at rhythms, scales, and speeds that are enabled by high-speed communications networks and ever smarter devices. So the question that we face, I think, is how to invent and devise new modes of transport. As we redesign urban and suburban centers, the two questions are interconnected. How do we move? What kinds of vehicles do we move with? And how do we design the spaces that are the spaces we live in, we work in, we play in? So the question that we face is, what are those new vehicles going to look like that will transform the way we move around the world and enable us to move more, better, further, faster, and more pleasurably, and more efficiently, of course, as well? And how might they assist underserved members of society, like the aging and the disabled, as they traverse the cities of today and of course, tomorrow? And the vehicles that will successfully address these kinds of challenges also will have to anticipate and shape new and emerging markets. Some of the challenges, some of the areas of opportunity that I see in my own work have to do with near-distance goods delivery, so-called last-mile delivery, questions of roadside retail, of how we've moved from a kind of fixed notion of the sales point to a much more fluid, mobile kind of concept of what it is to engage in commerce. Networked mobility systems for sports, for leisure, recreation, and health. The importance of lightweight fleet vehicles that can get into parts of cities that aren't accessible to traditional heavy industrial vehicles. Smart navigation across the boundary of indoors and outdoors. And the role of rovers, of other kinds of vehicles that are small, that are nimble, that are agile, particularly as applies to the needs of cities, to municipal fleets. And in that process of devising these kinds of vehicles, we have to also contribute to making our transportation systems more intelligent and responsive. We talk a lot about smart cities today, but our cities remain extraordinarily dumb. They have not been brought into the 21st century to a very large degree. They remain the cities of the 19th century with many improvements and enhancements, but nonetheless, we haven't fulfilled the promise of the smart city movement, which is at its inception still. So at PFF, at Piaggio Fast Forward, the company that I've led for the last 2.5 years, we are trying to pioneer intelligent approaches to the mobility of people and things at the right scale. And by the right scale, what I mean is a scale that lies somewhere in between the scale of automobiles and the scale of aerial drones, for example. Now that scale happens to be the scale of pedestrians, in other words, human beings, or of, let's say, of bicycles, or of skateboards. But it's smaller than the automobile, and it's larger than the scale of, let's say, a typical air drone. Now, as I mentioned, we're based in Boston, in the vicinity of Harvard and the Massachusetts Institute of Technology, and we are our parent company is the Piaggio Group, the largest European manufacturer of two-wheeled motor vehicles and one of the world's leaders in that sector. You may be familiar with some of its brands and products, famously the Aprilia high-performance motorcycle brands, including everything from superbikes to MotoGP bikes, Moto Guzzi, one of the historical motorcycle brands dating back to 1909, but most famous of all, the Vespa scooter, the scooter that changed the way that people moved around the world until the Vespa came along. By the way, the Vespa was a vehicle created by aeronautical engineers who hated motorcycles. And what they sought to do was to create a vehicle that would encourage women, for example, to become drivers of two-wheeled vehicles, that would encourage older people who would never straddle a motorcycle to get around the world. And the Vespa was literally a kind of disruptive vehicle of the 1940s. So now Piaggio Fast Forward is trying to bring this kind of expertise, 134 years of knowledge in the development of 2-, 3-, and 4-wheeled vehicles, to bear on the development of a new family of compact, nimble, and safe robotic vehicles that interact with humans in simple, rich, and intuitive ways. And of course, as I alluded to before, transportation systems are transitioning towards autonomy. But autonomy means a diversity of things. And what should it mean outside of highways, for example, outside of shipping lanes, or outside of airways? What about sidewalks, pedestrian areas, parks, civic spaces? Autonomy for whom? Who's the beneficiary of autonomy? To what end? Those are important questions that the public conversation about autonomy has not typically answered. And in the context of this transportation revolution that we're undergoing, of course, resources, the nature of the vehicle, the relationship of a vehicle to an owner is shifting from privatized models to models that involve sharing or networked communities, of course, largely thanks to the fact that we have computers in our pocket in the form of smart devices, of phones. And of course, those 2 billion pocket computers are accompanied by a lot of other computers that, in a sense, support the networks of pocket computers. And transportation, of course, doesn't exist in a vacuum. It's entangled with this whole world of networks, of computation, and of course, profoundly entangled with the devices that structure and support our everyday lives as they've developed since the digital revolution. With increasing, of course, we're challenged also with increasing energy demands and the needs to reverse global warming and protect the environment. And in this sense, we find ourselves truly at a critical juncture at this point, where vehicles have to somehow respond to that need, and at different scales. So at Piaggio Fast Forward, we're integrating existing and new technologies to increase efficiency, to help the environment, and to enhance the quality of people's lives by going beyond models of conventional vehicle design and trying to develop different typologies, new families of vehicles that interconnect people, vehicles, infrastructure, and services by adopting a holistic, human-centered approach to robotics. And we have some fun in this process, but we're also trying to lead the debate in a different direction. Some of you may be familiar with one of the foundational documents of the public conversation about robotics, which is Isaac Asimov's I, Robot, his 1950 text, which included, as you can see on the back cover, what became the famous 3 laws of robotics, otherwise known as Asimov's laws. And those laws were an attempt to begin to define an ethics for what that ought to govern the use of robots in human society. And at PFF, we've actually rewritten those rules. I'm not going to go into the details of our rewriting, but what we're trying to keep the focus on is the answer to the question of autonomy for whom, to whose benefit. What are the values that ought to infuse our design and engineering choices as we create these vehicles that extend the compass and range of our activities? Now, our mission at Piaggio Fast Forward is to pioneer the intelligent movement of people and goods, to help people move better, further, and faster in ways that have not been possible before. This is the spirit in which we're working, and in so doing, we seek to promote the walkable, livable, vibrant communities filled with enhanced transportation options that enrich the lives of everyone, which is why our core team is made up not just of roboticists and engineers, but also designers, architects, and urban planners. And the set of values that I've been talking about is what I like to call movability and autonomy for humans. And these are both values that are in line with the pursuit of vibrant, livable communities. So movability is what I started with, and it's really part of our company's DNA, so to speak, because the word was actually coined back in the 1960s to describe the Vespa, to describe smart approaches to transportation that focus on lightness, on agility, in particular vehicle categories that break down boundaries between the sidewalk and the street. And it's really building on this past that we seek to bring movability further into the age of robotics and artificial intelligence. As I hinted at in my opening remarks, movability describes what comes after the era of mobility, the era of automobility. It means responsive vehicles capable of sensing and interacting with their environment, vehicles endowed with collective intelligence that are environmentally responsible, cradle to grave, vehicles that leverage the power of human navigational intelligence to enhance the quality of machine intelligence, vehicles that are smart, clean, light, compact, and agile. And why not? Desirable, aesthetically beautiful, sexy, fun. Now that brings me to autonomy for humans. Now, the purist, you might ask, why autonomy for humans? After all, aren't humans already autonomous? And the purest expression of human autonomy is the fact that we walk. The defining feature of our existences is that we are bipeds. We walk on 2 feet. And walking is one of the most profound aspects of our existence, of how we interact among ourselves. And the rise of motorized vehicles, vehicles like scooters, like motorcycles, like cars, and like trucks and buses, of course, has extended this range. But however powerful and transformational, it also gives rise to dependencies. It gives rise to log jams. And as motorization expands, it ends up producing the pathologies with which I began this talk: gridlock, ever slower speeds of circulation, inefficiency, pollution, a diminished quality of life, not to mention the consequences of a sedentary lifestyle. I don't know if you realize that the speed at which we move around the world has actually been flat. It plateaued back in the 1970s with all land systems with the exception of high-speed trains. Airplanes are moving slower today than they were moving 20 years ago. That's because of traffic, crowdedness. Now, when the conversation about autonomous cars, about autonomous vehicles has arisen, it reflects this bias that I was just talking about. The models of autonomy that we've seen that have really occupied the public imagination have been proposed in terms of this is the standard document for classifying different levels of autonomy of a vehicle. You can see it's a 5-stage scale that runs from no automation to full automation, but you might call this autonomy for automobiles or autonomy for machines rather than autonomy for humans, because the entire focus is on diminishing the role of the human agent from driver to passenger. And there might be some very good things about that shift in roles, but what I'm trying to call your attention to is that it biases the conversation. And at Piaggio Fast Forward, we have a slightly different approach. When we talk about autonomy for humans, and I'm not going to go into all the details of the different levels of autonomy as we see it, we look especially at this question of autonomy for who. How does autonomy contribute to the quality of interaction between vehicles and their human operators? These are a complementary set of standards, if you like, that try to push the conversation towards this fundamental question of the value that's being created, the value that's being added. Now, PFF's first product is a mobile carrier that follows active people on the go, carrying up to 20 kilos, named Guida. And you're going to get to meet Guida in a second. Guida encourages a mobile lifestyle for anyone who wants to move with ease, from millennials to senior citizens. It's your answer to getting out of the front door, without reaching for the keys to the car. And we actually like to literally think about it as like a motor scooter for the 21st century, except you walk instead of driving it. As you can see, it's a fun and functional cargo droid designed to enable you to move freely and efficiently. And I'm going to ask my colleague Ben to come out here and bring Guida out for a walk so you can meet Guida as I'm walking here. So whether you're a neighborhood resident lugging bags of groceries around the block, an office worker who likes to run to work, a delivery person transporting goods, or a utility worker who needs their hands free to be able to perform useful tasks to work while trailing an intelligent toolbox, Guida is your movability helper, letting you walk instead of forcing you to drive. Now, I want to underscore that Ben is not carrying a device. He doesn't have a smartphone or a Bluetooth connection here. Guida is actually following him because it knows him, and it can tell him from anybody else in this room. Once it recognizes, it does a scan of his body. Oops. Robots are like kids. You know, when you put them on stage on the spotlight, they have a tendency to misbehave. There we go. There we go. So Guida is tracking Ben. It's done as a scan, just like the way facial recognition works, similarly using a LiDAR-based technology and a whole navigation package. Guida is tracking Ben. And important to note, Guida is a cargo vehicle. It has a cargo container. There we go. Ben's going to park it up on the stage and go down and distribute some literature. And this is the kind of use that Guida could be put to in everyday lives, which is you go out and you perform tasks that are useful tasks that involve moving objects around, whether it's a case of bottles of water or your groceries or books or your backpack. And then maybe you get to a certain point that's your destination and you park it, just like you would park a vehicle. But like a scooter, you can park it pretty much anywhere. You can park it on the sidewalk. Maybe it's not legal, but you can. There's a space. You can park it, close it, shut it down, and Guida has a whole series of systems that make it a kind of locker where you can leave stuff, park it, come back to it, pursue whatever tasks or errands that you have in mind that are part of your set of needs. So these are the ways in which Guida embodies a principle that we like to call granular mobility, thinking about mobility or movability, as it were, but from the perspective of that small-grained, fine-grained scale of rethinking the relationship between the sidewalk and the street, for example, looking at those really complex, cluttered urban environments like Mumbai or Hanoi, where you have this constant crisscrossing of agents, cars, scooters, people on feet, animals, that mix. How do we create vehicles that can navigate that kind of a space, that kind of a world where the pedestrian is the dominant factor? And if you think about the way cities actually work, it's at that kind of granular level. You want to just leave you to park there? Okay, great. So when we talk about a granular approach, we talk about looking carefully, not just at streets, but sidewalks, pedestrian zones, parks, bike lanes. And these are devilishly complex environments. They come complete with cracks in the pavement, with debris, with lots of moving agents from pets to fellow pedestrians. When autonomous cars confront a reality like this, they have problems because to understand how to navigate them, you have to understand human psychology. And human psychology, as the Google car found out very quickly, is extremely irrational. When a pedestrian puts his foot down into the street, it doesn't mean I'm crossing the street, it means I'm sending a signal to the driver of that car that I might cross the street. Similarly, all kinds of human behaviors are very unlikely to be quantified and operationalized as, no matter how effective and powerful AI is, it will struggle with these challenges, which isn't to say that we won't achieve solutions to some of those challenges, but those solutions are going to come by leveraging the power of human intelligence, the intuitive ways in which we, as human beings, know how to navigate these complex tasks and teach machines how to do so. That's what I understand as granular mobility or movability. The world is not about to be rebuilt to suit the needs of machine vision. A robot would ideally like the world to look perfectly perpendicular, rectangular, with all kinds of markings. That's not a very interesting world to live in. I don't think it's the world that we inhabit, and it may never be the world that robots have to navigate. So Guida, and I think a number of other devices like Guida, are learning to navigate complex routes by trailing an expert guide, which is you or me or Ben in this case. And in the process, Guida builds a three-dimensional map of the spaces it traverses, on the basis of which it can later perform autonomous navigational tasks, avoiding obstacles and detecting obstacles, even if those maps don't coincide to what it actually encounters along the way. So this brings me to autonomy for humans. What does autonomy for humans really mean? Well, it means leveraging that navigational expertise that humans possess. It means extending mobility multifunctionally and in a modular fashion. So it means moving around the world with your hands free, or it means vehicles that extend the range of human activity. Guida can travel about 15, 16 kilometers on a single charge. That's probably more than most of us walk in an entire day. 8 continuous hours of operation. I think above all, the kind of model of kind of vehicle design that it embodies seeks, as I think I've already said repeatedly, to democratize access to mobility by serving age categories of the population that have not been well served by automobiles or by similar kinds of mobility platforms. These vehicles are vehicles, as I said, that learn by trailing, by following. But most of all, perhaps most importantly, they're vehicles that allow us to do more, not less. They don't just substitute human agency, they expand human agency and human capabilities. But perhaps most revolutionary of all, when we typically think about motorized vehicles, of course, we think about vehicles that belong to the outside world. They operate on roadways, they operate in sea lanes, they operate in the sky. But these new kinds of smart vehicles that are created like Guida on a human scale, are vehicles that can operate across an indoor-outdoor threshold. Guida does not use GPS to navigate autonomously. It uses what I was describing before, a kind of mapping-based technology that's based on its following people and studying their movements and perfecting its pathways as it moves. It's indifferent to whether you're indoors or outdoors. And it can integrate into smart building systems and smart city systems. So as the world starts to change, as the world becomes smarter in the sense of more equipped with smart devices, whether it's elevators or doorways or any facet of a building, Guida becomes part of that ecology, part of that infrastructure. So a particular example of a smart behavior is elevators. Guida can learn how to take elevators, which means that you can travel in and out of any building that's built up to today's access standards. Guida does not do steps. Steps would be a very different kind of vehicle, but over the course of the last decade, buildings with step-based access are part of the past. They're legacy structures. Building codes today require access points that do not require going up and down steps. Guida also uses visual navigation, as I said before, not GPS, although we use GPS as a backup system, but we don't rely upon GPS because GPS works only in GPS-enabled environments, in other words, in the open air. The minute you move into a very tightly packed urban environment, you start to have problems with GPS. It's not reliable, and it's not reliable enough in terms of specificity. It updates its maps, it shares its maps, it can load maps, and it can establish autonomous navigation on the basis of waypoints. So you might ask yourself, well, what does the world look like to a vehicle like Guida? Well, this is sort of how Guida starts to construct its picture of the world. It's certainly not the picture, I'm going to close the vehicle. It's not the picture that we see when we travel around the world, but it's a picture that becomes the basis for constructing a model that's a shareable model. And you can imagine fleets of these vehicles in real time through the cloud, sharing three-dimensional maps of spaces that they travel in, and monitoring those spaces in ways that provide valuable information. But perhaps the crucial component here is access. Why a circular design? Two wheels that move side by side, as you see in this design. Why not 4 wheels? Why not 6 wheels? Why not 8 wheels? Well, there's one major advantage that is crucial to the design of Guida, which is Guida moves the way you do. It has a 0 turning radius. All the vehicles that you've had an experience of during your life of driving, many of you are not old enough to drive cars maybe, but bicycles and skateboards, you have to think about what the vehicle does when you're on a bicycle. You don't just say, I'm going to do an 170-degree turn on a bicycle. If you do that, you end up on the ground, right? On a motorcycle, forget it. You've got to lean in, think about where am I in the curve, when do I apply the brakes? Guida moves the way you do. It can spin on its own axis. It moves forward, backward, sideways. It doesn't provide a kind of pressure or friction, if you like, to your natural instincts. It also can travel up and down ramps. Any compliant present structure or future structure built according to today's international building standards, Guida can gain access to it. It can go over curbs and small sort of jumps, but it doesn't work on steps, as I said, and it probably won't ever. It's not designed to do that. It's designed to be a vehicle of the present and the future, not a vehicle that solves every problem in the past. Cars can't climb steps. Guida can't climb steps. An obvious feature: when you operate it, your hands are free. It carries approximately 20 kilos in its cargo bay, and it allows you to do all kinds of things that you probably would have required a car to do before, an automobile, simply because the goods you're carrying around are too bulky or too weighty. And maybe what you want to do as you walk around is work, if you're a maintenance person. Maybe you're operating an app because you're a delivery person. Maybe you're just texting your friends. Having your hands free is a different way of driving than the ways you're familiar with, whether you're grocery shopping or you're taking stuff out into the world, parking it somewhere, locking your Guida and with a thumb reader, and then moving on. And perhaps last but not least, it's designed to be intuitive, simple, elegant, from an ergonomic standpoint, as simple as possible, and communicative, because one of the biggest challenges with robotic vehicles is, and sometimes maybe out of an excess of optimism, engineers think, well, of course we can solve the autonomy problem. We can create these really cool robots, and they'll be on the sidewalks, and they'll be able to navigate. But when you see a robot heading towards you as a pedestrian on a sidewalk, you aren't necessarily, especially if it's really ugly, you're not going to look at it and say, oh, how wonderful, a robot to share my sidewalk with me. You might think, on the contrary, what the hell is that machine doing invading the space that was my space? Automobiles have the street, I have the sidewalk. What's this robot doing? So it's essential that the vehicles that expand our models of mobility be vehicles that inspire trust, that they're engineered to inspire trust, that they're expressive, communicative. And you probably noticed the lighting system, there's also a sound system. All of those are meant to speak to non-operators, not just to the operator, to work with the person who it's following, but also to inspire trust in non-operators, other pedestrians. Now, the current model, which you see here, which is the version 4 of the vehicle, you can see it has a touchscreen. And that touchscreen is actually going to go away. Our focus in our design process is to create basically the most natural and seamless relationship between the human and machine. Here, we'll be substituting the current touchscreen with just 3 buttons on the surface and some haptic interface elements. You'll log into the vehicle at the beginning with a smartphone, just so it knows you, it scans you, and after that, you walk. That's it. When you park it with a button. And it knows, basically its behaviors are behaviors you do not have to think about. The focus is on eliminating the screen. We spend so much of our contemporary lives staring at screens. Screens are very impoverishing environments. They're great. They do all kinds of magical things. But they also limit our activities in profound ways. We want Guida to be a vehicle that you have a one-to-one relationship with that is not mediated by a screen where you're having to get the vehicle. If Guida gets into trouble, it has a kind of haptic override, and you can just give it a little, steer it a little bit, and you can steer it through a really difficult passage, pick back up in the default functionality, and walk, and just keep walking. So as you can see, it's not hard to drive a Guida. Yesterday, we were at the elementary and middle school. We had about 35 or 40 kids practicing, driving a Guida. You basically, it scans your body, you log in, load it up, log in, and off you go. This is a gentleman who is a cancer patient. He can't carry weight. Whether you're in a wheelchair, it doesn't really matter. This is how Guida is seeing the world. It's filtering between different objects that are moving around, deciding which one is the one it's tracking, and there you go. And it is a high-performance vehicle, even though it moves at the speed of humans. It moves between a slow walking pace to a jogging pace, basically, not a sprinting pace, although it's capable of going that fast. We just don't feel confident about it operating at that speed. It's an electrical drive. It has the navigation package I was telling you about. And we've actually built them like a Formula One car. These prototypes that you see are made out of carbon fiber. They're super resistant, and they could go a lot faster, as I said. In the production version, which will be available in 2019, early in the year, it's not going to have so much carbon fiber. But it will be built to the standards, the rigorous standards of a race bike. And as I mentioned, it's an electric vehicle. You can plug it into a circuit in any wall, and in 3 hours, you'll be up to a full charge from zero. So the key issue here is enhancing the quality of life, whether it's city life or suburban life, life on campuses like this campus, or in all kinds of other environments to promote better, faster, freer, more efficient movement of people and goods. And what I'd like to close with here is a short video that gives you a kind of anticipatory vision of what a city might be, a world might be like, where that was dominated not by automobiles, but instead by smart vehicles like Guida. So thank you very much. If you'd like to take Guida for a test drive, we're going to move the robot out in front of the library, and there'll be an opportunity for you to go on little walks around the plaza there and to sort of experience what the world would feel like if a campus like the KAUST campus were filled with these kinds of new smart robotic vehicles. Thank you very much, and I'd be happy to answer questions.
You said that this is a microphone, you can literally just throw it into the audience.
Okay, very good. If there are questions, I guess I'll just throw. It's going to be a big throw here. Oh, not too bad. All right. Yeah?
Hi. I guess very obvious question. So I can't really... nice vehicle, by the way. Pretty fun. But what if we go and you suddenly end up in the center of crowd? I'm talking about big city, shoulder-to-shoulder crowd. What happened with my Guida?
Well, we were exactly in that situation yesterday when we were demoing it at the school. You can imagine a bunch of 6, 7, 8, 9-year-olds swarming around the vehicle. The vehicle does extremely well, actually. I brought it to TED in Vancouver this year. We had hundreds of people swarming around. It maybe every now and then it'll lose you, but most of the time it's able to constantly filter and differentiate. We have very, very refined filtering algorithm that keeps it tracking behind the person that it's logged in with. So in the future production versions of the vehicle, there will also be redundant systems. So if it loses you, there will be other signals that it will use to fall back on to catch up with you. But the point you're bringing up is an important point, because when we get into extremely high density environments, of course, a vehicle that can detect obstacles and avoid obstacles is going to find itself in increasing difficulty if the density is so great that it basically paralyzes it, that it has to stop. So for us, the engineering challenge is to find the right balance and to be adaptive, especially. In other words, the vehicle needs to have an intelligence that allows it to see the difference between those different operational environments. So I'll give you an example. The following distance. So you saw with Ben leading Guida. Guida's following what we have it set at about a yard, a meter? I think it's about 2 meters. 2 meters. It's set about 2 meters. If you're running, you want a bigger following distance. If you're walking, you want a shorter following distance. You might want a really small distance. Let's say you're in a situation like you were describing. So basically, what's important is the dynamic nature and the adaptive nature of the vehicle, its ability to differentiate between those different kinds of operating environments. Yeah. So yeah, it's about, as you can see, about 2 meters, but those will be user-settable parameters. So let's say I log into my vehicle and I know I'm going to a crowded market and I want Guida really close to me. I would say, follow me at 75 centimeters. Right, follow me really closely. I'm going to be moving slowly, but I want you to follow closely. If Ben were to be changing speeds in our production model, accelerating or slowing down, basically what will happen is it will change the following distance automatically. So those are parameters that'll be user settable on a mobile app as part of the login procedure. There were some other hands up here. I don't know. You want to just throw it? Yeah.
Here's the mic.
Yeah, it's on.
Thank you for the wonderful presentation. How much does it cost to manufacture one Guida right now?
Well, so what you're seeing is obviously a prototype. It's a part of a fleet of prototypes. We have about 20-some Guidas right now. The production models will probably be somewhere in the price range of a motor scooter, somewhere in there. But we haven't set prices at this point. And there will be more advanced versions that have higher level navigation packages that will cost more, and a baseline model that will be closer to the price I was mentioning. So that's roughly where we are. Because, as I said, these are really experimental vehicles. We built them using techniques that are unlikely to make it into the industrialization phase. So, this is a carbon fiber vehicle. Your average consumer is not going to need a carbon fiber vehicle. An injection molded plastic one will do just fine.
Thank you.
You've mentioned an electric drive, so
Yeah.
I'm wondering whether you guys have a system of keeping it secure from hacking or attacks based on the electrical drive.
Yeah, well, so security is obviously a very a fundamental concern because any vehicle can be used for good or for bad. So we have a whole series of security components to the system that at the level of the login procedure, also the ability of people to hack the networks, for example, that JITAs are operating on, that make us comfortable that we've designed them with enough levels of control and oversight that we can avoid the kinds of security challenges you can well imagine. But there's no absolutely perfect bulletproof solution to that, just like there isn't for cars. What we can do is build in prudent kinds of controls that make it very difficult and to constantly anticipate the misuses people could engage in with regard to the systems. One thing that's different and distinctive about these kinds of vehicles, as well as cars today, is of course that they are increasingly vehicles that are on networks. So there can be oversight not only at the local level of the operator, but also at the level of the fleet operator, for example. So in addition to a mobile app, there will be a web application for people who are running fleets of these vehicles, which will allow people from a remote location to see the operation of all of the vehicles in the fleet. The same is true for us. Like when we send them out into the field and we do pilot testing, we can actually see what's happening with the vehicles. And that gives you certainly, it's not a guarantee, but it's a layer of at least monitoring that is reassuring when it comes to misuses. So there's no perfect fix, but there are a lot of prudent ways to attack the question of security. No. Other questions? Yes.
Why did you choose to start with a vehicle that transports objects instead of humans? Is it like to encourage walking, or
Yeah.
are there other reasons?
Yeah, that's a great question. So we're very much interested in human transportation as well as the transportation of goods. But when we were looking around, when the company was founded in about 2.5 years ago, we looked around at the different areas where some of the most exciting work is going on right now, and felt that in the whole domain of the transportation of people, there's a lot of money, a lot of smart people, a lot of major companies committed to reinventing the automobile, for example. And it didn't seem to make sense to us to focus on a market like that. In the realm of aerial drones, there's same thing is true. Some very smart teams of people working on different designs for drones to transport cargo, to perform a whole range of tasks, including transport people. But where we saw a real weakness was in these other realms of mobility that were getting almost no attention in the technology community. And very early in that process, I think as I mentioned in the talk, our team is a team that has just as many engineers on it as it does architects, designers, people who deal with the built environment, the world we live in, the physical world. And we were really struck by the way in which pedestrian environments had been largely left outside of these sorts of futuristic, innovative approaches to transportation and mobility. And we thought, for a small company like we still are, that was a particular area of opportunity to invent new kinds of categories of vehicles that are not familiar to us, but that might dovetail with the kinds of visions of the present and future city that, as I tried to suggest, have been emerging and become powerful elements in the way in which we plan and shape cities. So it was both a kind of strategic choice and one that was informed by a particular interest that we have. But if you had come to our headquarters a year ago, you would have found a prototype 3-passenger car as well. So it's not that we're not interested in people. We thought it would be more interesting to start with vehicles that promote pedestrian-based lifestyles, and then to move more broadly out into a whole family of vehicles that might eventually make it to vehicles that transport people.
Hi.
Hello.
Thank you for the presentation. First, second, I have a question about the security. Is it like, you mentioned something about like if you push the button, then it will follow you by your map or something?
Yes.
So if like another person like pushed the button, would that be like, okay, he stalled it and that's, like that's it?
Well, so the way that this prototype version is set up, that could happen. So your question is well-founded. But in the future versions, basically, instead of what Ben did when he came and stood in front of it and just pushed the button, and of course you could come up and push the button and go away with Jita, right? What would typically happen is you would have a mobile app on your phone. You'd go in, stand in front of the vehicle, log in, and it knows you. Like it would keep a scan of you. And only if you, as the operator of Jita, enable it, permit somebody to step in and take it from you, so to speak, you pass it on to somebody else, would it follow somebody else? So the control systems that you see here are just for this demo prototype version, but eventually it will be possible to create, just like think about how you use social media. You'd create a family of users. Those are authorized users. You know, they can all, they have, some of them maybe different degrees of permission. Maybe some will always have permission to take your Jita out for a walk. Others maybe like with special authorization where you get a text message and it says, can Ahmed borrow my Jita? Yes. He's registered as a friend, but not a family member. Those kinds of distinctions will be possible. So the idea is it's a social vehicle. It's not an individual vehicle. It can be shared by communities. It could be a piece of urban infrastructure, maybe a city or a neighborhood or a campus owns 20 of them. They're all parked in a certain place in the lobby. You go grab one. You're part of the family. You plug in. But if my friend comes in from out of town and tries to take a Jita, can't get on because he doesn't have the app. He's not registered. All of those kinds of access and control systems will be part of the production model.
Thank you for the presentation. I have a question. If it's in the parking mode, can someone sit on it to rest or?
Could one sit on it?
Yeah.
I guess you could.
So it's stable?
You could. I mean, the vehicle is very robust. And people always ask us, well, what if somebody walks up to my Jita and tries to steal it? It weighs about 35 kilos without being fully loaded. So yeah, you could try to, but first of all, the vehicle will go completely crazy. If it knows it's parked and you try to steal it, alarms go off, lights go off, you're not going to want to steal a Jita. It's going to be difficult. You'd want to hack it first and then steal it. Good luck. We're going to make it very hard for you. But sitting on top of it, yeah, maybe. You could. When it's parked in the production model, it will actually sort of rest so that it's not using power. The version you see here is always self-balancing, so it's using power up. But so yeah, you could, yeah, like you can see so it's not powered right now. Ben's just rolling it, right? Yeah. So yes and no.
I have another question
That's fine.
that came up actually when the mister said something about the crowded places.
Yes.
So I was thinking about like metros, and like when you go in the metros and the door is like open just for like maybe 5 seconds or something. So like, I mean, that would be really easy to lose your Jita.
You're like, oh no.
Yeah.
Yeah. Well, we're very interested in this idea of the vehicles as part of a kind of infrastructure, if you like, and so it's conceivable that they could be operated in those kinds of environments. I mean, at present, most metro systems are still pretty unfriendly environments, even for human pedestrians. They have a lot of steps, and they're difficult environments to operate in. So I don't think it will be the first place that we focus on. I think we're much more likely to focus on new kinds of work, live, retail, like residential quarters, like multi-city block developments, where Guida could easily operate both autonomously in the follow-me mode, or campuses like the KAUST campus, large spaces where you perform a lot of tasks where you need to move things around, resorts, hotels, parks, those kinds of environments. They pose less challenges than metro systems, although why not? It's conceivable that eventually metro systems will be part of that.
Hi.
Hello.
In your design, how much do you focus on improving the way humans move now and changing the way humans move?
That's a really good question, and where one of the areas of development that we're just beginning to kind of grapple with is using machine learning to perfect the human-machine relationship in terms of the following. So people, humans don't all walk the same way, as you were implying. Some of us walk more in a more linear fashion. Others of us, walk in a more zigzaggy fashion. And Guida's intelligence ideally would be able to capture those differences and adapt to them as part of its adaptive behaviors. But you bring up an interesting point, which is how might this be a training device, for example? How might it go beyond simply adapting, but maybe become a vehicle that leads or that promotes certain ways of moving? And that's something we're very interested in. So one of the design features that it's maybe not very clear here, that but is part of our future development plan, is what we call drop-ins. That cargo bay doesn't have to have a lid on it. When the touchscreen goes away, we don't need a lid. So we'll be able to drop into the cargo bay all kinds of very specific units that allow you to do things that are specialized kinds of tasks, for example. And of course, we have power. Like, we have a power source here. So we don't need to be plugged into a wall unit. And that could be really interesting for rehabilitation, for training, for all kinds of tasks that involve changing the way people move, not just mirroring the way people move. So your question is a very good question, and it's definitely part of our longer-term plans. Currently, we have one Guida that's operating at an experimental a restaurant cafe space that's called the Art Science Cafe in Cambridge, where we have it powering a series of units that are electrical that allow you to have a gastronomical experience at your table, where it's the Guida power source that's actually running the vaporizers that turn these liquids into a kind of olfactory experience, for example. So why not, a trainer or something, a tennis ball launcher or whatever. Yeah, we can do that, definitely. That's one of the cool things about an electric vehicle, is it can power anything you plug into the system, right?
Hello?
Hello?
So I was wondering if the Guida could traverse different terrains such as desert or forest or gravel or grass, such things.
Yeah, so that's basically most hard surfaces we don't have any problem with. Like grass, you probably saw there were some kids playing with a Guida in a park. Gravel, generally no problem. When you start to get to mud and snow and really light sand, that's more challenging. So any hard surface, no problem at all. We've experimented a little bit with other wheels for the vehicle. It's possible that we could create an off-road version. We haven't done it yet, though. It's a good question.
Hello.
Hello.
So does the Guida give any warnings when the charge is about to go off? Because that might be a huge problem.
Of course. It does, and those lights you see around the periphery, not only do they communicate what it's intending to do to non-operators, to people walking around. Like, for example, when it turns, it gives you, just like a car, like a signal light on the back. You can see, like, oh, Guida's turning. It's going left. It's going right. But also, similarly, like if there's a warning, like let's say it loses a connection, like we saw when Ben got over to the corner there, it'll flash. And similarly for battery charge and any other set of signals. If If we had a couple of hours here, I would have walked you through the whole way in which it interfaces with humans. But as I said, the focus, a lot of our design effort is very much on this issue of making it a vehicle that you can intuit the behavior of. You don't have to think about it. There's no manual you have to sit and read. If you've ever programmed a drone, you know what I'm talking about. You spend a huge amount of time trying to think about the strange ways in which the device has been programmed to behave. Our aim is to eliminate that, to make it so intuitive that you can literally walk up and start operating it right from day one. So
one more question, the last question.
Okay.
I have it. Can you
Yes.
hear me? As a person, I'm sure a lot of us do a lot of traveling in airports. I hate luggage pulling. I'm wondering if there's a way to develop a set of Guidas that could be 3 luggage pieces that would follow me to my gates and follow me. No, really, and perhaps even work in such a way where the people in the airport who are moving it to the plane would be able to get luggage on.
Yeah, it's a great question, and the answer is yes. And so you may have noticed in the slides, there were a couple of slides that showed another vehicle, which is a heavier duty 3-wheeled vehicle. That's part of this family of vehicles, basically uses the same technology platform. But all of these vehicles are capable of convoy operation, so platoon operation. So if a Guida can follow a person, it can follow another Guida, right? So along the lines of what you were suggesting, you could be walking with 3 of them following you. Airports are very interesting environments because they're places where we carry a lot of stuff. And pushing carts around is useful, but maybe not always the best solution. And also, it isn't just us as passengers, it's also the personnel, as you mentioned, who have to move stuff around. So yeah, that's a market that we're looking at very closely, and we're planning to do some test piloting at some of the world's airports that are really thinking about the future of airport mobility. So yeah, that's a very interesting domain.
We would like to thank you very much, Jeffrey and Ben as well. So I have one trophy only, so I will give it to...
Oh, thank you.
Join us for the...
Oh, thank you so much.